Hello everyone, welcome to my YouTube channel. My name is Precious, and in this video we'll quickly look at the concept of binomial expansion. Right, so for us to begin to talk about binomial expansion, it means that we understand the meaning of a binomial expression. So when is an expression said to be a binomial expression? That's when it is of this form. So whenever you have a combination of two terms which are actually called monomials, of course, in this channel, I have discussed polynomials, and under there, I explain what a monomial is and what a binomial. These are forms of polynomials. A polynomial is said to be a monomial if it contains only one term. So, for instance, x is a monomial, 2x is a monomial, 10 maybe y is a monomial. So this is a monomial in y, these are monomials in x. So and then a binomial is now an expression, an algebraic expression that contains two terms. So for instance, is of this form x plus y, where your x here can be anything. Your x can be 2x, it can be 10x, it can be anything. So if I have something like, let's say, 10y minus maybe 5. This is a monomial. In this case here, if I want to put it of this form, it means here that my x is equal to 10y and then my y is equal to -5. So the first term here stands for the x, that's using this expression here, while the second term stands for your y. So simply put, that a binomial is just a combination of two algebraic monomials or two algebraic terms. Okay, so now the expansion of a monomial is always of this form, say x plus y to the power of n, where n is a positive integer, right? So how do we expand this? That's exactly what we want to look at. Now that doesn't mean we don't have monomials, binomials that we expand, maybe, or we raise to the power of a fraction or a negative power and all of that. So, but now we are going to be beginning with the one of a positive integer n. Okay, so how do we do this expansion? Now, there are two things to take note of, in the expansion of binomial expression. Now, the first is that you are going to have a set of terms that will be formed when you do the expansion. And then the second is that each of the terms in that expansion is going to have a coefficient. And so you will need to know how to find the set of terms and then also how to get the coefficients of the terms. For instance, if I have x plus y to the power of 2, now if you expand this, you are going to get x squared plus 2xy plus y squared. Now in this case here, now the coefficient here is 1 and the coefficient here is also 1. So there are the set of terms here which are x squared, xy, and y squared. And now there's a set of the coefficients which include 1, 2, and 1. Okay, so the two things we are going to be looking at is how to find the set of these terms and then also how to find their coefficients. Okay, so now meanwhile, please note that this is addition and this is addition here. So now we're going to be checking how to do all of this. So I am going to begin with the first one. So how do we get the terms? But before we even go here, now it is important for us to note that whenever we do an expansion, there you are going to get a number of terms in the value that you will get from your expansion. And of course, we're going to see that later on. But just to mention it here, that the number of terms you are going to get at the end of an expansion is always equal to the power of your expansion, which is n, like what we have here, then plus 1. So what that means is that if I expand x plus y to the power of 2, I should be expecting 3 terms, which is 2 plus 1. And that's why we have what we have here. And so if I expand x plus y to the power of, let's say, 5, and so the number of terms should be 5 plus 1, which is going to be 6. So what this does for you is that it gives you an idea of what to expect for every single expansion you do, even without doing that expansion, right? And so now we are going to look at the process of generating the different terms in every expansion that we do. Okay, so now the first thing to note there is what I just mentioned here. The number of terms that you are going to see is always n plus 1, where n is the power of your expansion. I've given examples. And then the second thing is that, so if I have x plus y to the power of n, what it means is that the first term will always be x raised to the power of n, while the last term will be x raised to power, sorry, y raised to the power of n, and then other terms will be in between. And so an instance is if you have x plus y to the power of 3, for instance, the very first term is going to be x to the power of 3, and the last term will be y to the power of 3. And so, and then there will be terms inside here. So since this is to the power of 3, using the first one here, it means that I'm going to have two more terms here because there will be a total of 4 terms. Okay, and then the second thing, or sorry, the third thing to note here is that if I have any expansion that I'm doing, then the each of the terms that you're going to get, remember we said that for x is to the power of n, you're going to have n plus 1 terms. For each of the terms you're going to have, which will be a combination of x and y. For instance, if we use the example I gave before, where we have x plus y to the power of 2, and I said that this is equal to x squared plus 2xy plus y squared. So you could see that this is actually a combination of x and y. Why? Because I can actually write this as x squared times y raised to the power of 0, and this one is x raised to the power of 1, y raised to the power of 1, plus then x raised to the power of 0 times y raised to the power of 2. So you can see there's a combination of x and y in each of the terms. Now, this last point is telling us that every term you have here, that the sum of the exponents is going of x and y is going to be equal to the total power you have here. So since we have 2 here, you can see here the sum of the powers here is 2 plus 0, which is 2. Here the powers here is 1 and 1, 1 plus 1, which is 2. Here plus 2, which is actually equal to 2 also, right? So that's actually what to expect, and that's what the third point is saying. And then the fourth point, which is also important, is that the power of x, or the first term, remember the x here represents is just a symbol, a representation, is it stands for the first term. So the power of the first term will always start with the highest power. Like in this case, you have it starting with 2 here, and then it will keep reducing by 1 until it gets to 0. And then the power of the second one will start from 0, and it will keep increasing by 1 until it gets to the highest power. And one beautiful thing is that by the time it gets to the last power, x will be 0, and your y will now be the power of the highest, which I have here, which is actually 2. So, and that's these are the 4 critical things to note on how to generate the different terms that will be present in any expansion. And then we want to look at how to now generate the coefficients. Okay, there are 2 ways that we can actually handle this. One of it is what we call the Pascal's triangle. Okay, here we only form is going to give us numbers in triangular array. So your Pascal's triangle begins with 1, and then on the side here you now have 1, 1. Then here you now have 1, and you sum these two, which will give you 2, and then you have 1. So it will always start with 1 and end with 1. And then on the next one, I have 1 here. The sum of this is 3. Here is also 3, and then you end it with 1. The next one will be 1. Okay, so now what does this stand for? This will be the coefficient of the terms when your n, which is the power of your expansion, remember we have x plus y all to the power of n. So when the exponent of your binomial expression is equal to 0, you are going to have 1. And what does that mean? Anything to the power of 0, if I have x plus y to the power of 0, I will get only 1. And so now when our n is equal to 1, then the coefficient of the two terms will be 1, 1. It's just, for instance, if I have x plus y to power 1, of course, this is the same thing as x plus y. So what's the coefficient of this? 1. The coefficient here is also 1. And then when your n is equal to 2, then the powers will be this. You remember the example I just gave here? Our n here is 2, and the coefficient here is 1, the coefficient here is 2, the coefficient here is 1, and that's exactly what we'll get here. And so when your n is equal to 3, then these are the coefficients you are going to get. So you can see that this is actually giving us the picture of the first thing I talked about in forming the terms. Here, because the n is 3, the number of terms is 4. You can see it with the coefficient. Here, because the n is 4, the number of terms will be 5, and you can see it with the coefficient, and so on and so forth. Now, however, we make use of the Pascal's triangle to generate the coefficient of our terms when our n is not that big. So, but when we begin to have sizable amount of n, then we go to another approach of generating coefficients, which we call the combination approach. All right, and so what is the combination? That's the normal combination we just did under permutations and combination. Okay, so what is this approach saying? You can also use combination to get all these coefficients, and this is the way it goes. So if I want to expand this, for instance, then the coefficients are simply going to be n, which is the power here, combination 0. It will start with 0, and then I'll keep going n combination 1, n combination 2, until I get to n combination n. So what it means is that if I want to work on x plus y to the power of 2, therefore the coefficient is going to be, it will start with 2 combination 0, then the next one will be 2 combination 1, and the next one will be 2 combination 2. And of course, you can see you have 3 terms. And when take if you simplify all of this, it will actually give you this 1, 2, and 1. We can check that. What is 2 combination 0? Of course, there is a rule in combination that tells us that if I have n combination 0, that it is equal to n combination n, and both of them are equal to 1. So no matter the number, if I have anything, say 3 combination 0 is equal to 1. If I have 3 combination 3 is also equal to 1. So that gives us these two as 1, and this one also 1. Okay, and we can actually check it. Let's do that. So if I try to find 2 combination 0 by formula, n combination r is equal to n factorial all over r factorial times n minus r factorial. So what it means is that if I do it here, my n is 2 all over my 0 factorial, then multiply by 2 minus 0, which is actually 2 factorial. And of course, this 2 factorial will take away this, so I will have 1 all over 0 factorial is also 1, which is equal to 1. And if you do the same thing here, you will also get 1. And then what about the 2 combination 1? 2 combination 1 is simply equal to, so there we are going to have 2 factorial all over 1 factorial, then multiply by 2 minus 1, which is actually 1. And when you simplify the down, you have 1. 2 factorial is 2. So that will give you 2 over 1, which is actually equal to 2. So that's how you can also get the coefficients. So that means if I want to expand maybe x plus y to the power of 5, therefore my coefficients are going to be 5 combination 0, 5 combination 1, down to 5 combination 5. And so that's going to give me about 6 terms also. So now basically we've seen how to get the terms of an expansion and how to get the coefficients also. So now let's quickly look at some examples. Right, so we are beginning with the first set of examples here. For the first example here, I want to expand 2 plus 1 over x all to the power of 3. So in this case here, my x is 2, my y is 1 over x. So now, because our power is 3, we can actually make use of Pascal's triangle to generate this because of our time. So I'll begin with 1, 1, 1, then I'll have 1, 2, 1. This is for 0, this is for 1, this is for 2. So I'm going for 3. So I go again. This is 3, this is 3, and this is 1. So these are the coefficients that I need. Okay, so let me just expand the terms and then attach the coefficients. Of course, the first and the last are 1, 1, so no need to put anything. So I'll begin with the first one here. I'll start with 2 to the power of 3, which is the highest power. then multiply by 1 over x to the power of 0 plus the coefficient for the second term is 3, so I'll put 3 here. Then multiply by 2, the power will reduce to 2. Then multiply by 1 over x, the power will increase by 1. Then plus the next coefficient is also 3. I'll multiply by 2, the power will reduce again to 1. I'll multiply by 1 over x, here the power will increase to 2. And finally, the last coefficient is 1, no need to put it. So I'll have now 2 to the power of 0, and then I will now have 1 all over x to the power of what? 3. So ordinarily here you can see that 1 over x to the power of 0 is 1. So there was actually no need to put this. That's what one of those rules I stated earlier, that you should start with your x to the highest power, and in the last one you have the last term to the highest power also. So but we of course we have done the expansion and it has given us the same thing. So this is equal to 1, and 2 to the power of 0 is also equal to 1. So all I have here now is 8 plus, now here I'm going to have the 2 to the power of 4 is, sorry, 2 to the power of 2 is 4, times 2, sorry, times 3 will give us 12, and then multiply by 1 all over x to the power of 1 is the same thing. Then here I'll have 2 to the power of 1 is 2, times 3 is 6, then multiply by, now remember indices, the power will go on the numerator and denominator. So 1 squared is 1, x squared is x squared. And then finally here, we are going, of course, this is 1, so we're going to have 1 all over x cubed. And so if we try to rearrange this so that the coefficient here will become the numerator. So we're going to have 8 plus 12 all over x, and then plus 6 all over x squared, and finally plus 1 all over x cubed. So this is actually the solution to this expansion. So we are done with the example 1. So let's really look at the second example, which says that we should expand x plus 2y to the power of 4. My first term here is the x, the second term here is the y. So by that first rule, what it means is that by power of 4, I'm going to have 5 terms. And so see what I'm going to do now. I'm going to have that the first term is my x to the highest power, which is 4. And then the second term is my x to power 3 multiplied by my y to the power 1. And then my third term is x to the power 2 multiplied by my 2y, which is my y to the power 2. Then plus, remember, because the power is 4 here, so we're expecting 5 terms. And so the fourth one is going to be x to the power 1, then multiplied by my 2y to the power 3. And finally, remember, the last term is going to be the whole of this, which is my y to the power 4. And that's going to give me 2y to the power of 4. Of course, my x will now be to power 0, which will actually give me 1. And so these are the terms now. So let's try to put the coefficient. Remember, this is power 4. So let me go back to this place. So at this point, if I want to now get the coefficient of 4, let me remove this. The coefficient for power 4, remember this one is for power 3, is now going to be, this is going to be 1 here, and then here will be 4, then this is going to be 6, this is going to be 4, and then I have 1. And so you can see 1, 4, 6, 4, 1. There are 5 terms actually. So I'm bringing them here now. So I have 1, 4, 6, 4, 1 also. And then so finally, I'm going to have x to the power of 4 plus, of course, 2. Okay, let's just do that. This is going to give us 4x, so multiply by 2y. Then this is going to give us 6x squared multiply. Of course, once you open this, you're going to have 4y squared, because the square will come on these 2. And then here we have 4x into, this is going to become 2 raised to the power 3 is 8, and then times y raised to the power of 3. And finally here you have 2 raised to the power of 4 is 16 multiplied by y raised to the power of 4. So if I open the bracket, finally, I am going to have x to the power of 4 plus 2 times 4 here will give me 8x to the power of 3 times y, then plus 4 times 6 here will give us 24, x to the power of 2, y to the power of 2, plus 4 times 8 here will give us 32, then x to the power of 1, y to the power of 3, and finally we'll have 16 y raised to the power of 4. And that's the solution. And of course, you can check for each of the combination of terms we have here, the sum of the exponents is always equal to 4. Okay, and that's the solution for this example. Now, this one here says we should expand this. So what is it going to give us? Now we are going to is up to power 6. Okay, let's try to do that. I'm going to expand the terms first, then later we'll add the coefficients. Okay, so I'm beginning with the first one, which is x squared to the power of 6, because this is my x in this case, and minus 1 over x is my y. So, and if you raise it to power of 0, it will go. Then plus the same x squared to power 5 now, then multiplied by minus 1 over x to the power of 1 in this case. Then plus again x squared to the power of 4 multiplied by minus 1 over x. Remember to carry this minus 1 over x. The negative sign here is part of your y. It's not only this. Remember, here must be positive, and if you put plus here, you still have minus, even if you remove it. Okay, so so from here we are now going to have x squared also to the power of 3, then multiply by minus 1 over x to the power of 3 also. Sorry, this is to the power of 2. Okay, so if we continue that way, we'll have x squared here. Okay, and we are done with this. So all we need to do now is to try to expand everything and then simplify. Remember, I am still leaving the coefficients out. We'll still bring them in. Okay, so here now, if I open this bracket, I will have x to the power of 12, then plus, don't mind that I'm using capital here. All everything here is actually x, the same x. Okay, so now this one is now going to be x to the power of 10, then multiplied by, sorry, remember this minus will multiply this plus here to now give us minus here, and then you are now multiplying by 1 over x. Okay, then plus here we'll have x to the power of 8, sorry, x to the power of 8 multiplied by, remember that minus squared will be plus, so this is just going to be 1 all over x squared. Okay, and then here we have, remember that the odd power here, the minus will still remain, so let the minus come out here, it will give us minus, and then x squared raised to the power of 3 is x raised to the power of 6, then multiplied by 1 all over x cubed, and then the power is even, so the minus will disappear, so we'll still have plus here, and then x to the power of 4 multiplied by 1 all over x to the power of 4, and then here we now have odd power, so the minus will remain, so we'll have minus x squared multiplied by 1 all over x to the power of 5, and then finally the power here is even, so the minus will go, so we still have plus here, so we have plus x, sorry, 1 all over x to the power of 6. And all we need to do now is to finally cancel out where we can. So this is x squared. Then here, x will remove 1 here, you have 9. So that will be minus x is to the power of 9. And then plus here, the squared will remove 2 here, you will have 6. And that is x to the power of 6, and here x will, the 3 will reduce this to 3. Remember, we are using law of indices here. Division will change to subtraction, so you have x to the power of 3, and then here now power 4 will cancel power 4, so you just have only 1 here, and then here you have squared here will reduce this to 3, so we just have 1 all over x raised to the power of 3, and finally we still have our x to the power of 6 here. Okay, so we are done with the expansion of the terms. Now we need to bring in the coefficient of these terms. Now remember that the coefficient, we can actually form these coefficients ourselves. So let's try to form it here with this space. So we have 1, 1 here. This is 1, 2, 1. This is for order 2. and then we have 1 3 3 1, that's order 3. Then we have 1 4 6 4 1, and then we have 1 5 10. This will be 10 also. This will be 5 1. Remember, this is order 4, this is order 5, and finally for order 6 we'll have 6, we have 15, we have 20, we have 15, we have 6 and 1. So we have 1 6 15 20, and then back again. Okay, so let's fix them here now. So finally, it means now that our x squared minus 1 all over x all raised to the power of 6 is going to be equal to, of course, the coefficient of this is 1, so I'll leave it as that. Then minus the next one is 6. So you have 6 will be here. That's 6x to the power of 9. The next one will be 15. So that's 15 to the power x to the power of 6. And then the next one is 20. Okay, and then that means that 20 is multiplying this minus x, sorry, minus 20x to the power of 3. And then the next one is 20, so that 20 will multiply this one to give us 20 here. And then the next one is the next one is 15, not 20. After 20 you have 15 again, so here will be 15, and then the next one will be 6 again, so you have minus 6 all over x to the power of 3, and finally you have 1 again. That means this will still remain as 1 over 6, over x raised to the power of 6, and this is our solution. We can actually rearrange this and bring the constant to the back if we want, and we can also leave it this way, and that's the solution to this problem. And that is where we'll end it for this video. Please kindly subscribe to our YouTube channel if this is the first time you are seeing our videos. Like, comment, and share our YouTube videos. And in our next video, we are going to see other problems, the part 2 of this concept on binomial expansion. We'll see you in our next video. Bye.